Hi, Algebra 1. I hope you're doing well today. Hey, a reminder, if you still need time to finish up that test that we took the other day, please come in, or any of your tests. Let's try and get those done so I can get your grades updated. Some of you owe me a couple of things, so double check PowerSchool, and if you see a 0 in for a test or quiz, come in during one of your off periods and make it up. If you see a 0 in for a homework assignment, get it done and show me, or perhaps you even have it done and you forgot to show me. So we had page 71, 72, 13 through 19, so you probably realized 13 through 19 was only on page 72. So let's work through these. Number 13, we have x minus 4 times x equals 0. So we have two parts of this problem. So we'll set each of those equal to 0. Add 4 to both sides here. And this one's already set up. So those are the solutions. That's where it would cross the x-axis if we had graphed it. And we have x plus 1 and x minus 4. Those are equal to 0. Set each of these equal to 0 and solve it. So subtract 1 from both sides. Add 4 to both sides. Problem number 15. This is our problem. So set each of them equal to 0. Add 3 to both sides. Subtract 14 first from both sides. Then divide both sides by 2. So you get x equals negative 7. So again, if I had taken 3 and plugged it in for x, or I plugged negative 7 in for x, my answer would come out to be 0. So notice these are equal to 0. Okay, number 16. We have to factor this one out. This is what we had been doing, so we'll multiply those together. So I get positive 35. All the signs are positive, so I have two positive numbers. And I believe 5 and 7 are going to work because those will add up to 12. So positive 5x and positive 7x, plug those in for the 12x. If you're having trouble with factoring, please come see me. I'm off periods 4, 6, and 8, or come see me during advisory. I factor an x out of both of those. The middle sign comes down. This is what we have been doing. We factor a 7 out. I'm left with that. So they have x plus 5. I'm going to set that equal to 0, and then I have x plus 7. I'll set that equal to 0. So subtract 5 from both sides. And subtract 7 from both, subtract 7, so I get negative 7. So if I plug negative 5 into the original equation, or plug negative 7 into the original equation, it would equal 0. Number 17, we have x squared minus 6x plus 9 is equal to 0. I'm going to go ahead and multiply those together, so I get positive 9. Because I have a negative sign there, and that's a positive sign, both of these have to be negative. So the two things that multiply together to give me 9 are 3 and 3. They multiply together to give me, if I multiply the two together, I get positive 9. If I add the two together, I get negative 6. So let's factor this out. Bring down that negative sign. Let's factor a negative 3 out of both. Remember, both signs change. So we're going to get x minus 3 equals 0 and x minus 3 equals 0. Add 3 to both sides. So this one is, when I graph it, it actually, let's graph this equation on Desmos. I just want you to see what happens with it. So again, you don't have to know how to use Desmos at this point. It'll be something that we will work with later. Oops, get that. So I get y equals x squared minus 6x plus 9. All right, notice this. It only kisses the x-axis. So if we look back at our answer, the answer itself, we had 3 and 3. So that we had the same answer happen twice. That's why it happens there at that situation. So in math, when you're graphing these, when you have a double root like that, or the same exact two answers, it usually means it's going to kiss the x-axis. So touch it once. It doesn't go through it, it just touches it. Number 18, I have x squared plus 13x minus 30 is equal to 0. Let's multiply those together. I get negative 30. In order to multiply two numbers together to get a negative, one has to be positive and negative. And so let's do positive 15 and negative 2. Make sure you have an x with both of those. That'll give us the 13. Let's factor an x out of both of those. Bring down that negative sign. Factor 2 out of both of those. So my answer factored wise looks like this. And then I can just set both of those equal to 0 and solve both of those. So subtract 15 from both sides. Add 2 to both sides. And it's done. All right, then number 19. They want to know where the person had made the mistake, saying, hey, these were the answers. And the big, oops, that's a 3. The big problem that happened here is it's equal to 4. If that needs to be a 0 in order to say the answers would be 5 and negative 3. So if this is not 0, then you can't solve it that way. Okay, we're going to be on page 73. Let me get to it. There we go. So I just have these 8 problems to work on. So a couple things. We are going to solve these like we had been doing. Here's the problem. They're not equal to 0. So you want to make them equal to 0 first. So I'm going to add 3 to both sides. So I get x squared minus 4x plus 3 is equal to 0. And then we're going to go ahead and factor that. This one I would want to subtract 9x from both sides. This one I'd want to subtract 6 from both sides. Notice I'm making them equal to 0. This one I'd want to add 4 to both sides. This one's already set up, so we're good there. This one's set up. This one I have to move 2 things. So I'm going to keep 3x squared. I'm going to add 20x to both sides. I'm going to subtract 32 from both sides. And then I make it equal to 0. And then this one we can go ahead and solve it. So let's go ahead and see if we can work through these. So let's multiply those together. So I get a positive 3. So I'm going to have 2 negatives. So I have negative 3x and negative 1x. Plug them in. Factor an x out of both of those. Bring down that negative. Factor out a negative 1. Change both signs. So x minus 3 equals 0, so x equals 3. X minus 1 equals 0, so x equals 1 by adding it. There's your answer. On this next one, I can factor an x out of both first. Then I'm going to take both parts and set it equal to 0. So x equals 0 is the first one. Add 9 to both sides here. So we get that. Number 3, make 1 out front, and I get a negative 6. So I have a positive and a negative. Oops, I covered up my problem. I want to make it negative 5, so I'm going to have a negative 6x and a positive 1x. That'll add up to negative 5. So x squared minus 6x plus 1x minus 6. Let's factor an x out. Bring down that middle sign, factor a 1 out. The signs all stay the same. So I'm going to get x minus 6 equals 0, so add 6 to both sides. X plus 1 equals 0, so subtract 1 from both sides. Looks like that. Problem number 4, we're going to multiply those together. Oops, I'm covering up the problem, I'm sorry. So that's going to give me a positive 8. Because I have a negative sign right there, both signs will be negative. So I have negative 8x and negative 1x that I'll plug in for that. So I'm going to get 2x squared minus 8x minus 1x plus 4. So I'm going to bring a 2x out, factor a negative 1 out, change both signs. X minus 4 equals 0, add 4 to both sides. 2x minus 1 equals 0, add 1 to both sides, divide by 2. So my answers are 1/2 and 4. This one, when you look at it, this was one of those special cases. This is the difference of two squares. So this becomes x plus 2 and x minus 2. Okay, remember you don't really have to factor because x times x is x squared, 2 times 2 is 4. There's a subtraction sign. Let's set these equal to 0. So subtract 2 from both sides. Add 2 to both sides. There's my answers. For problem number 6, I can factor an x out of both. So I'm going to get x equals 0. X minus 3 equals 0. So there's one answer. Add 3 to both sides. There's my other answer. Number 7. Ooh, remember we had to do an awful lot to this. We can multiply those together, and that's going to give me negative 96. Let's see, negative 96. So I have a positive and a negative. I want to figure out what factors would add up to 20. 1 and 96 don't work. 2 and 48 don't work. 3 and 32, they're not going to add up to 20. 4 and 24. Oh, 4 and 24, those would add up to the 20. So I need a positive 24x and a negative 4x, and I'll replace that there. So I got 3x squared plus 24x minus 4x minus 32. Let's factor a 3x out of both of those. So that's going to give me x plus 8. Factor a negative 4 out of both of those. Remember, middle sign comes down. So then I'm going to get x plus 8 equals 0. So subtract 8. So there's one answer. And then I get 3x minus 4 equals 0. So add 4 to both sides. Divide by 3. And you can leave these as fractions. That's fine. Problem number 8. I could factor a 6 out. That's going to be x squared plus 1 equals 0. Ooh. So this one, it looks like it's different two squares. I can't solve this. Okay, I want to show you what's going to happen here. Remember, we have them either touching the x-axis or not touching the x-axis, or touching the x-axis twice. So let's plug this one and see what it actually looks like. This is a good one to kind of verify our mode might work, because it's not the difference of two squares. So I have 6x squared plus 6. And look at this. This right here, this is the x-axis. It doesn't cross it. So this creates something called not a real solution. And the real solution, when use the word real, we're talking about the real number system. Okay? So sometimes if you can't factor out, maybe just go to Desmos and take a look at it. And if it doesn't cross the x-axis, your answer is not a real solution. Because real, the word real means you're talking about that number system. It's called the real number system. There's lots of number systems. You have the real number system, you have the integers, you have the counting numbers. There's something that's called the irrational numbers, the rational numbers. There's all these different number systems that are named. This actually is part of something called the complex number system, which your answers are part of, I kid you not, this is a funny name, part of the imaginary number system. And that's really the true name of it. Okay, so I think you have enough to get a pretty good start on page 75 and 76. And would you go ahead and do 1 through 18? Again, if you're having trouble with the factoring, why don't you come see me when I'm done teaching and let me walk through it with you, okay? I hope you have a nice day. Bye-bye.